Hello everyone, and welcome to Matrix Plots lecture with seaborn. In this lecture, we're going to learn how to create matrix plots, primarily heat maps, using seaborn. Let's go ahead and jump to the Jupyter Notebook to get started. Okay, here I am at the Jupyter Notebook. I went ahead and said import seaborn as SNS, and then set matplotlib inline. Then I loaded up two datasets. I've loaded up the tips data frame, or dataset, using sns.load_dataset and then passing in the string tips. And I did a similar thing for the flights dataset, using sns.load_dataset and then passing in the string flights. The tips dataset we've seen before, here's the head of it, but the flights dataset we haven't, so let's take a quick look at it. The flights dataset primarily just shows the number of passengers that flew in a given month of a given year. Now let's talk about heat maps, which is our primary way of showing some sort of matrix plot. In order for a heat map to work properly, your data should already be in a matrix form. And what I mean by matrix form is so that the index name and the column name match up so that the cell value actually indicates something that is relevant to both of those names. Let me show you what I mean by that. For instance, if I take a look at the tips data frame, right now I have total bill, which is some sort of label or variable, and if I look at one of the values in this cell, it's $16.99. However, the row is not an actual variable. In order to get this into matrix form, I need to have both variables on the columns and the rows. I can do that through many methods, usually through a pivot table or trying to get correlation data. We'll go ahead and do correlation data first. If I call tips.corr, close parentheses, now I have a matrix form of some sort of data here. And what I mean by that is now the column and the index variable names actually indicates a relevancy to both the column and the index name for the cell where they match up. And this is the matrix form you're going to need your data in order to call heat map on it. And then it's actually just as simple as calling sns.heatmap and then your data. Let's go ahead and save tips.core as tc and then pass it into heat map. And here we can see a heat map. All a heat map really does is it colors in those values based on some sort of gradient scale. So if I take a look at my original TC data frame, it's essentially just set these numbers to a gradient on a color scale and then filled it in. And that way, if you have a very large correlation data frame or some other matrix form data, you can easily tell what the numbers are, what the values are relative to each other using a heat map. And that's the main primary use for a matrix plot. Other useful arguments you can pass in here to heat map besides just your data is annotation. So you can say ANNOT as an argument equals true, and it will annotate the actual numerical values that belong in each of these cells. So you don't just have to go off of color, but you can also go off of the actual value here. And then you can also specify as CMap the actual color mapping you want. We'll go over color maps and the options later on in the seaborn lectures, but for instance, just to show you an example, cool warm is a string that verifies a color map, and here you can begin to see the color map cool warm on the same data. Now let's revisit the flights data. I'm going to go ahead and type in flights, and we can see we have all this year, this month, this passengers, and I need to get this into matrix form, meaning I need to somehow convert one of these variables up here to be the row names, the actual index. So I want one of these variables, either year, month, or passengers. Let's go ahead and say month to be the index. So I'm going to say the index is equal to month, and then I'm going to go ahead and set the columns equal to the year. And then the only thing I have left to do is specify the values, and that's going to go ahead and be the passengers column. Let's go ahead and run this and see what this looks like now. Okay, now I have my data in some sort of matrix form. You can do this with pivot table quite easily, depending if your data lines up correctly. But now you can see I have a bunch of numbers here that correlate well with not just the column variable, but also the index variable. So I can see here in 1952, for instance, in April, there were 181 passengers. Now what I want to do is use heat map to quickly visualize this data. I'm going to go ahead and set this equal to FP for flights pivot, and then just call SNS heat map on FP. And here we can see the heat map for the pivoted tables of flights. And now I can see, based off a color gradient, the data in a lot clearer of a format. So I can easily tell which month of which year had the most flights. And it makes sense that gradually, as the years go further or forward in time, you get more flights. And that makes sense because as time goes on, more people are on airplanes, more flights are occurring. And you can also see, based off the month, that popular month to travel is usually during the summer months, June, July, and August, at least for US data. Now, what you can also do is add in arguments such as CMAP, and let's go ahead and show another example of a CMAP. One that's useful is magma, and now we can also see from dark to light the actual colors here, the variation. Another argument you can pass into heat map, which sometimes people like to use, is line color and line widths. Basically, right now in this heat map, all these cells are touching each other directly, but sometimes you may want some separation. So you can specify line widths to be a little thicker. We'll go ahead and put in 1 there, and you can also specify the line color. I'm going to go ahead and specify it to be white. Now if I run this, I get these lines in between each cell, and sometimes that's a little easier to read. You can make these lines really thick if you want more separation, and you can also change the color of the line. So for instance, if I go back to maybe another CMAP, another one sometimes people use, like we shown before, is cool warm, and this is what it would look like. Maybe you want something that's not white. You can also choose like black, for instance. So really you have a lot of customization here as far as how you actually want to separate this. Let's go ahead and remove everything and just show the original heat map here. Now let's talk about the second matrix type plot in seaborn, which is the cluster map. And the cluster map is actually going to use hierarchical clustering to produce a clustered version of this heat map. Let me go ahead and show you an example. Here we have the original heat map, but now I'm going to call SNS cluster map on FP. And notice what we have here. We have the data. I need to zoom out to show this completely. But now we have the data and these little hierarchical clusters. And this basically tries to cluster columns and rows together based off their similarity. And this essentially shows the years and the months in clusters, and the months here on the y-axis you can see are no longer in order. They go September, June, August, July, October, April. And the reason for that is because they've been clustered to most similar months being put together. And the same thing for years. You can see certain years are now out of order. It goes 1949, 1950, 1953. Then this basically clusters the information to try to show columns and rows that are similar to each other. So I can see now that 1959 and 1960 are very similar to each other, and so are August and July. And you can see the different levels of the hierarchy of the clusters based off of these kind of tree diagrams, both on the y-axis and the x-axis. And now you can really begin to infer information from a plot. In order to make this even more clear, what we can do is change the color mapping, so CMAP equal to the string cool warm again. And now we can really see the clusters. So now you can see that there's a cluster between August and July very clearly. And something else you can do is standardize the scale. So right now we're still on passengers from 0 to 600, but if you wanted to normalize this, you can pass in an argument called standard scale and input 1, and this would normalize this from 0 to 1. And now you can really see, based off a normalized scale, the similarities of the clusters based off the coloring. So it looks like these November, January, and February, these kind of early winter months, are much closer to low passengers, and high passenger count is mainly in these summer months. Okay, I encourage you to go ahead and explore the documentation for cluster map if this is something you're interested in, but you may want to wait until we actually get to machine learning clustering algorithms so we can better understand what's actually going on with the mathematics behind these methods. For now, you can just think of it as an interesting method to just infer a little more information from a normal heat map. A heat map will display things in the order you put them in, a cluster map will cluster things in an order so that similar groups are close to each other. All right, thanks everyone, and I'll see you at the next lecture.